I hope you're doing great today. This is our chapter number 19, and today we are going to start with Git. Guys, this is our chapter number 19. So, in the last 18 chapters, we have covered what is DevOps, what are the most popular DevOps tools, and what is Linux file system, and I have created a 5 hours course on Linux system. After that, we started with our first DevOps tools, which is Docker. And in Docker, we have covered almost everything regarding Docker, which is suitable for DevOps beginners and DevOps engineers. After that, I have also created a 6 hours video of Docker course, in which everything regarding what is Docker, how Docker works, what is a Docker file, how to build, pull and push images, 50 Docker commands, Docker volumes, Docker networking deep dives, and Docker help. And also we have covered some basics of Docker Compose. Now guys, it is time to start with our second DevOps tool, which is Git. So I request you to please subscribe my YouTube channel, because we are going to cover all these important DevOps tools one by one. So I'm sure that now you have a clear path that how we are moving along with DevOps tools. We have prepared our base, which is Linux operating system. We have been working on Ubuntu. Now, after that, we are able to work with Linux CLI, and then we ran 70 plus Linux commands. Now, after that, we started our first DevOps tool, which is Docker. Now, it is easy for us to work on Linux CLI, and now it would be really easy to work with all the DevOps tools, because on the day one, guys, I told you that it is mandatory to learn Linux to work on all other DevOps tools. So Git also works on Linux, and also it works on Windows as well. And the good news is the man who created Linux also created Git. So in this chapter, we are going to cover only what is Git. So let's get started. Guys, we know that it is the responsibility of the developers and the software engineers to write code. And in the IT organizations, we have seen that a lot of developers, multiple software engineers are working on a single project. For instance, a single project can have 10 or 12 or 15 developers working on the same project. Now, how the code of that project is managed? We use Git to manage and track all the files, all the changes happening with that code. So if I am asked what is Git? Okay, define Git. So the simplest and the shortest definition of Git is it is a DevOps tool which is used to track changes in your code. Yes, guys, this is the simplest and the shortest definition of Git. It is a tool to track changes happening in your code. Who is working on which file? Now let us understand Git a little bit more with this diagram. Guys, for instance, this is my project. I am working on an e-commerce solution. This is my project, e-com solution, okay, e-commerce store, you can say. Now there are multiple developers working on this single project. This is developer A, okay, dev A. This is dev B. This is another developer, dev C. For instance, this guy is also a software engineer. I would also use the term software engineers, because software engineers, developers are working and writing the code. So they are definitely, every time they are attached with Git and working with the Git repositories. For instance, he is a software engineer and he is also attached or working on the same project with the development team, and he is the guy. D, there is also another person, software engineer, who is working on this project. And so there is, for instance, there is a total team of 5 developers and engineers working on that project, and this team is led by a development manager. Okay, so this guy is a manager and he is managing all the team, the developers, software engineers who are working on this single project. So if we are not using Git, how can we assume that developer A, what is he working on? How can we know that what is developer B is working on, or software engineer D is working on? So Git simplifies and it helps us to know what are these developers working on using Git, because every developer has a separate branch. So each developer will create a separate branch, and on that branch he or she will write the code, and that code is merged with the master branch. Okay, there should be a master branch which contains the final version of the code, and that master branch is managed or looked by the development manager. So each developer, that's how actually happens in the IT teams. A developer, the team of developers write the code in their branches. When that code is properly tested and that feature is tested by the QA team, then that branch, so for instance this is branch A, B, C and respectively, and the guys will tell that the code is ready and it can be merged with the master branch. We will study about the branching strategy in Git and why it is necessary to create branches for the code. But for now, you need to understand that this is my project and this is the team members of the development and software engineering team. So they are working on a single project, and Git is helping them to avoid conflicts, because each developer and the software engineer is writing the code. So in order to avoid the conflicts, they will create separate branches, and those branches are merged with the master branch after testing and verifying the code is working fine. So we can say that Git is the most popular version control system which tracks the changes happening with the code, because each developer is definitely writing the code and making some changes on that project. So Git is actually tracking the files and changes happening with the code. And not only that, guys, Git also maintains the previous versions of the code. For instance, I have written that code, but for some reason that code is not working on a specific branch. With the help of Git, since Git maintains the versions of the code, I can bring any copy of the previous code and I can start working on that piece of code right away. So that is why Git is known as the version control software, because we can have multiple versions of our code. Now guys, there is another term that is mostly used in Git, which is distributed version control system, because Git is actually a distributed version control. I should have told you that in the first place, but I wanted you to clear the concept of the version control, the software version control. And there are actually two types of version control: the centralized version control and the distributed version control. Centralized version control. And now distributed version control is used, and there are a lot of benefits of distributed version control as compared to the centralized version control. So actually there are two types of version controls: centralized and distributed. So what is centralized version control? As the name says, that centralized version control, in this approach, the project is located at a single location. It means that we have the only one copy of the project, and all the developers and software engineers access that location, that project copy to work and write the code. Whereas in distributed version control, we can have the full and fledged multiple copies of the project on multiple computer systems. So distributed version control gives us a broader access of our code. Now let's compare both version controls with a diagram. My fellas, it is mandatory to have the concepts cleared regarding centralized and distributed version control. However, since we are working with Git, because it is a distributed version control, but still we need to understand the concept and the difference between each version control. So in centralized, this is centralized, okay, version control, and the example is SVN, subversioning, SVN, okay. And in centralized version control, we have only one copy of the code, and this is, for instance, my repo, okay, code, and I have the only one copy of that code on a single server, and multiple developers are working on that code from their computers. This is PC1, this is PC2, and this is PC3, okay. But the problem is that they are writing the code which is stored in a single centralized location. We don't have the multiple copies of our project, of our repository, or of our code on multiple locations. The location is one. The location is centralized, and the developers access that location, access that code from their personal computers, from their PCs, to write and make some changes. And that's why this approach is known as centralized version control. Now let's discuss distributed version control approach. In the distributed version control, like Git is the best example of distributed version control. We have this repository, or our code, or our project repo code, and we will have the multiple copies of that code, okay. This is another copy, full-fledged copy of our repository. This is another copy, and this is another copy. And now the developers are working on that code. They have the full copy of the code on their personal computers. This is also the repo, and this is the copy of the repo, this main repo, and this is also the copy of the repository. So in centralized, we just had only one copy of the code, but in distributed version control, we can have the multiple same copies of our main repository or main code, and all these repositories can be accessed from different working personal computers or desktop systems. This is PC1, this is PC2, and this is PC3. So that is the difference between centralized and distributed version control. In centralized, we had only one copy of the repository or code, and multiple developers are working on that code, and they are accessing only one central location. But in distributed version control, there can be multiple copies of the repository or our code, and each developer can have that full project on her or his PC. I hope that now you understand the difference between centralized and distributed version control. The example of centralized version control is SVN, subversion control, and the best example and our favorite version control is Git, which is distributed version control. And using this version control, we can have the full copy or the full code repository on our personal computers, on our PCs, on our desktop systems. Now let's discuss some beautiful facts of Git. Git was actually introduced by Linus Torvalds, the person who gifted us Linux. And also, he is the creator of this version control, which is Git. Now, guys, there are around 95% of the developers working on the whole world are relying on Git for their code. And the beauty of the Git is we can have this single project. This is my project, and I can have thousands of branches. These are branches of that single project using Git. So it means that hundreds or thousands of developers can work along a single project using branches, and it is easily and linearly handled by Git. I was searching about Git on Google and I found a really interesting question. So I thought that I should share it with you guys. What is the difference between Git and GitHub? Are they same? No. Git is a version control software which we can install on our personal computer. Okay, this is my personal computer and I can install, because Git is open source, it is free, and I can install it on my personal computer and I can manage or write my code. But GitHub is a service which runs Git in the cloud. This is cloud, and in GitHub, Git runs in the cloud. So we can say that we can install Git on our personal computer. It is a version control software, whereas GitHub is a cloud service which runs Git on the cloud. Git is a free software, whereas we have to pay for using the GitHub online services, and there are packages on github.com. So guys, I'm sure that whenever you are asked about the difference between Git and GitHub, you can answer that Git is a free version control and we can install and we can work on our personal computer, whereas GitHub is a Git service in the cloud. Alright guys, now let's wind up this lecture. We have discussed the basic concepts of Git. Git is a version control system which helps to track the changes happening in our code. We also discussed the two main types of version control: centralized version control and distributed version control. Since we know that there are a lot of benefits of distributed version control, where we can have multiple copies of our code, multiple copies of our project on different locations, whereas it is not possible in centralized version control, where we have only one copy or single location where our project is located. There are a lot of benefits of distributed version control. That's why 95% of the developers around the world now use Git. And you saw that we can have multiple developers, multiple software engineers. They are working on a single project at the same time without any conflicts. So that is the beauty of Git. And another big thing that I like the most related to Git is it is open source. It was developed by Linus Torvalds, who is the creator of Linux operating system. So this would be open source and free for the rest of our lives. And also we discussed about the difference between Git and GitHub. Git is a version control and we can install it on our personal computers, whereas GitHub is a cloud service where we can work on Git in the cloud. And guys, don't worry, we can work on GitHub for free. We are going to use GitHub in our next lecture. So in the upcoming lecture, we are going to discuss about a couple of Git terminologies, like what is a repository, what does clone mean, and also we will see how Git works. So the second chapter is also one of the important chapters. Make sure that you go through this chapter and have your basic concepts of Git cleared. I will see you in the next lecture, where we are going to discuss how Git works. So make sure to subscribe my channel. I will see you in the next video. Hey guys, I hope you're doing great today. This is our chapter number 20, where we are going to talk about how Git works. My fellas, in the previous lecture, we discussed about what is Git. And we also discussed the difference between the centralized version control and distributed version control. We know that Git is a distributed version control system. It is open source and freely available. When we install Git, we can create repositories, we can commit changes on our local VM. But we also discussed about the difference between Git and GitHub. Git is a version control on our local system, whereas GitHub is a cloud service which provides Git in the cloud. Now we must know how Git works. So that would be actually a lab session in which we are going to practically install Git on our Ubuntu Linux VM. We are going to install GitHub GitHub CLI on our VM. We are going to create our first repository on our VM, and also we will create a repository on github.com after creating an account on github.com, and also we will create a personal access token so that we know how can we commit changes to our repository. So I would highly recommend that you must watch this lab session to clear your concepts about Git and how Git works behind the scenes. These are actually behind the scenes of Git functionalities. And if you have not subscribed my channel, I would request you to please make sure to subscribe DevOps Molvi on YouTube. Let's start our Git session. Alright guys, I am logged in my VM. So first of all, we need to check whether Git is installed on my local VM or not. So I will check which Git, and there is no output of this command, so it means that Git is not installed. So the command to install Git is simple as apt install and git. Okay, and I will give the password of my user and the Git will be installed. Okay guys, you can see the Git has been installed. Now if I run which Git, you can see we have the binary here, and now I would be able to run the Git commands. Git, and you can see there are a lot of Git commands we can see, and there would be a separate Git commands lecture, and we will try to cover each and every Git command in that lecture. So starting with how Git works, let me create an empty directory, mkdir DevOps repo. Okay, now this is my repository here. I'm going to initialize a repository in DevOps repo. This would be my folder. Now I will run git init command, git initialize, and an empty Git repository would be initialized. Okay, now you can see it is saying using master as the name for the initial branch. So the master branch would be created, and I have this repository initiated. Okay, now we can see the Git folder, hidden Git folder here. You can see .git, and it, guys, it is, you can say, the database of Git. It contains everything regarding our repository. So when we initialize an empty repository using git init command, so this folder .git is created here in the same repository, and now we would be able to run Git commands, and we are now able to commit and change our files and modify the files. So we have that repository initialized. Now I will check the status of this repository. So the command is git status. So you can see that it is on master branch and there are no commits yet. I have made no changes in this repository. Okay, so first of all, I will create an empty file. Okay, this would be my first file dot txt. This is my file, and now I will run git status again, and it will show us that there are some changes in this repository. Git status. And guys, now you can compare both outputs here. It says that on branch master there is nothing to commit. This is a totally empty repository. Now there is another output and it is saying there is an untracked file. Okay, now we are going to learn three stages: untracked, staged, and committed. Okay, now first stage is saying that this file is untracked. Okay, so it means that the file has been created but it has not been staged or committed. It is a standalone file. Now we have to add it and then we have to commit it so that it can be pushed and tracked by our Git repository. Now this is an empty file. Okay, so what I will do, I will add so that it moves forward to the next stage. Guys, always the files are in the first stage, which is known as untracked. These files are not being tracked by Git. We have to add them to the repository so that they are going to be tracked. Now in untracked files, Git does not know if there are any modifications or if there are any changes happening with these files. So we have to add our files so that Git start tracking, and that stage is known as staged files. Okay, so I will use git add and dot. So it will add our files into the staging phase. Okay, now we will run again and you can see that this file is now being tracked and it is saying that you can run this command to unstages to move it from Git tracking. Now Git will see what is happening with this file. Git will have a 24/7 look on this file because it is in the tracked stages. Now I will create a new separate file and we will again see the difference. Okay, touch my second file .txt. Okay, now I haven't added it. Okay, so we can see there should be one untracked file and one staged file. So there are two phases. I hope that you now understand that there are, now we have studied, we have practically saw that there are two stages. One is untracked files. The second stage is staged files, and the third stage would be committed files. Okay, now git status, and you can see that there are now two stages showing, but still I have not committed any changes to the repository. Now this is our staged file. Now this is our untracked file. So if I run git add and dot, the second file would also be included in the staged phase. Now again, git status, we can see that there are now two files and both are in the staging phase. Now for instance, git log, this shows that there are no committed, though there are no commits. Git log shows when there are some commits. So we will definitely see when there would be some commits in the files. Now again, I will modify the file and then I will commit the changes. Nano, my first file and I will modify it. This is my first change in the file. Okay, now again there would be the status of Git would be changed, and we can see it will say that this file has been in the modified state. Okay, now I hope that you're getting the difference. First there were untracked files, then we added them in our Git staging phase, the staged files. Now again we modified the file to see whether Git is now looking our files and monitoring and added and logging the changes. So yes, this is true, because we have modified the file. This is my first file .txt, and I have modified it. So now what would I do? I will again add these modifications into the file. Okay, and I will run add git add, and now again git status. You can see our file has been updated and it has those previous changes, and now I will run the git commit command so that our changes can be committed. So git commit and -m, which is message. -m stands for message, my first change. For instance, this is the message, and now you can see that there is the output says that there are two files created in this comment. Okay, this file, the second file, two files have been changed. Two files were created, and there was insertion, there was I mean there was something added in one file. Now guys, I will again modify this second file, nano my second file. Okay, and this is my second change. So I'm changing the second file. Now git status. So without watching the output, what would be the change? One file would be in the modified state, and what would be that file? It would be my second file. Now we can see this file has been modified. Okay, and now again I will run git commit -a command to add the changes so that our repository is updated. So I will add this file git add, and now git status. You can see that this file was modified, so it means that the file is now staged. And for instance, if I do not want this file to be staged, I can run this command is given by Git itself, that if you want to unstage any file, you want to remove it from being tracked, then you can run this command. So let's run and see the output. This file, and now I can see this file would be in the untracked state. Now again I will add it, git add, and this. Now again I will commit git commit minus with the message. This is my second change. Okay, and now guys, you can see that there was only one file changed and there was only one insertion. Okay, so you can see that there was only one file that was changed and there was only one insertion. Now I will see the git status, and there are no comments. Sorry, git status, and you can see there are no comments, nothing to commit, working tree clean. I mean that those files have been modified and they are added and they are now staged and committed. So guys, I hope that now you understand that there are actually three, or you can say there are four phases if we add modified as well, but as per Git there are actually three stages. First is untracked, second is staged, third is committed. Okay, I hope that now you understand. For instance, if I add a new file, it would be first in the untracked stage. Now after I add it using the git add command, Git will start tracking it, and it will be in the second stage, the stage files. And after that, if I commit, then this would be the committed state. Now we can run the git log files, and it would show us about the commits git log. Now you can see we have this log git log command to see the logs of the commits that have been made by the developers. What are the developers committing, and what is any DevOps engineer or software engineer is committing. So we have this log git log using the git log command. And if I change anything, then after commit, there would be the log would be updated. And now guys, we can see another. Let me repeat it a little bit more quickly. I will create another file, touch my third file, okay, third file .txt. Now again I will check the status, it would be untracked. Now I will add it, git add, so that it is in the staging phase, staged. Now I can see the status has been changed, but now again I will modify it. Nano, my third file, this is my third file, and I will save it. Now there would be another status that the file has been modified. We can check it. You can see it has been modified, and it is also being staged. Now I will make a couple of changes in my third file, nano my third file, and you can see I will create some changes. This is my fourth change, okay, fifth change. It means that there is some code being added, okay, sixth change and seventh change. Then I will run the git command to see the difference between the first version of the file and the current version of the file. Git diff, this command will tell us the difference. Okay, now you can see that there has been some changes to the file, and it says that these were the changes. Now I will also change the second file, nano my second file, and fourth change, one change, two change, three. Okay, I will change here as well. Now again we will run git diff command, and you can see that it is also showing my second file is also being changed, and these were the changes. So guys, that's how we can see what were the changes in the previous and the current versions of the file. Now these were actually the changes. Now if I run git status command, you can see that both files have been modified, and therefore I will run git add to add these changes, and then git commit -m final changes in the code. For instance, this is my message. Now you can see that two files were changed, okay, there were two files that have been changed, and there were actually 11 insertions. Wow, this is beautiful, because we have the track record of all the changes, how much insertions, what were the changes, how many files were changes. We have all the record. And guys, I told you that there is actually a hidden folder which is .git, which maintains everything for us, and it is just like a database of Git. Now guys, I have this repository, and I have all these files. Now I want to push this local repository DevOps repo to my GitHub account. Now, this is something really interesting. When I was practicing it, I found it really interesting, and I hope that you will enjoy it too. First of all, you must have a GitHub account, github.com, so you can sign up on GitHub for free. You can create your personal account, and you just need an email and password, so you can have your account on GitHub to create public and private repositories. Now I will click on the sign up button, and I just have to give my email address, and you can see this user interface is literally so beautiful. By the way, I have my account already created on GitHub, and I have a couple of repositories, and we are going to push this repository which is created on our VM. It is a local repository. Okay, now I want to move or push everything, every file, every change to my GitHub account. So first we must have GitHub CLI installed. So GitHub is actually installed via this command, sudo apt install GitHub. I have already installed it, but this is the command, and it will let us know that GH means GitHub CLI has already been installed. Now if I run GH command, GitHub, you can see that there are a lot of GitHub commands as well. Now these commands help us to play with, to work on our repositories that are hosted on our GitHub account. Now this is my GitHub account. I have a couple of repositories here. This is actually the dashboard. You get the repositories you follow. If they have any update, then you can see all these updates here, and this is actually the dashboard of my GitHub account. And similarly we can create, I'm not sure, okay, welcome to GitHub, let's begin the adventure. For instance, if I sign up DevOps Molvi at gmail.com and continue, and it will just ask for the password. Okay, and since I don't have to create a new account, I'm just letting you know, guys, that this is that simple. You can create your free GitHub account using your personal email address and password, and you can have unlimited public and private repositories on GitHub. I'm sure these are unlimited. Let me check if there are any packages, etc. Sorry, GitHub plans. By the way, there are a couple of plans. We have these plans offered by GitHub. Okay, and there is the enterprise plan. This is team, and this is for students and beginners and DevOps engineers like us. Okay, so you can have everything to work with using this free plan, and you can create a free organization. Just I told you that you can have unlimited public and private repositories on one account. This is amazing. And you can have 2000 CI/CD minutes per month. CI/CD we will definitely going to cover in our next section. That was after finishing Git, we are definitely moving towards GitHub Actions and CI/CD. And you can see that there are other features, but this enterprise plan has a lot of features. And I'm sure that the organizations with a large code base definitely buy enterprise plan. And my previous company had this team plan where every account was costing $4 per month, and you can see that everything which is offered in free plan is already included, and there are other features offered in this team plan. And for large organizations with huge development and coding and software engineering teams, definitely rely and purchase this enterprise plan. And by the way guys, it is actually 21 US dollars per user per month. For instance, if an organization has 100 employees and it will create 100 accounts, then definitely they will have to pay 2100 US dollars for all the employees, for all the developers. So that's how we can also purchase our GitHub account for our team and enterprise. Okay guys, now these are my repositories. You can see on the left hand side of your dashboard, you can see all the repositories, and this button is used to create a new repository. So we can create a new repository from here as well. I will discuss it later. This is really simple to create any public or private repository for your code. Let's push this repository to GitHub. So gh command is gh repo create. You can see it here. Gh repo create, clone, fork, and view repositories. So I will use gh repo create. Okay, that is the simple command, and the same repository will be hosted on our github.com account. Okay, now it is saying that create a new repository on GitHub from scratch or push an existing local repository to GitHub. So I will use this option, push an existing local repository to GitHub. I want to push this DevOps repo to GitHub. Now, what would you like to do? Push an existing local repository to GitHub, path to local repository. Dot means the current path where I am currently now. I'm in DevOps repo directory, so I will use this path. Dot, okay, dot. Now repository name, the same name. I would like to use DevOps repo, and any description like this repo was created from Git from command line, because we have created this repository from command line, and now we are going to push it to GitHub. And now, do you want to have this repository public, private, or internal? For now, let's suppose I want to have this repository as private. Okay, this would be my private repository. Okay, now it is saying that HTTP 401 bad credentials. Try authenticating with GitHub auth login. So it means that we have to first authenticate first, and I wanted to replicate this error, so we need to first authenticate with our GitHub account from our VM. So I will run this now, and I will. What account do you want to log in into? Okay, it is saying that which account do you have? We have on github.com. We do not have GitHub enterprise server, we have github.com. So I will use this, press enter. So what is your preferred protocol for Git operations? So guys, this is, by the way, GitOps. Okay, we are also learning about GitOps as well. These are all Git operations. So I want to have HTTPS login with a web browser or paste an authentication token. So I will definitely paste an authentication token here. Now you can generate a personal access token using this URL. Okay, I will use this URL. The minimum required scopes are repo, read org, workflow. I mean to say that these are minimum requirement for the token must have these accesses. Paste your authentication token. So first, now we need to create the token. So I can paste this URL, and instead of this URL, if you don't know this URL, we can go from here under my profile picture. We can see the settings here. Okay, we're sorry, these are the settings, and in settings, this is my profile, and here I can use the developer settings, and it will lead us to personal access tokens. So I can create tokens here using the classic tokens, and I can generate new token. So you can go from here as well. This option under your profile, go to settings and then developer settings, and then we can create the token from here. So now I will generate a new token, okay, a new classic token. So I have to authenticate. We can see that we have these a number of options, and these are actually permissions that we can grant to our token. So here it just told us that our token must have the repo, read, or and workflow access. But let's suppose that I will just create a custom token just for one day. By the way, I will delete it because this token is everything. Your GitHub account access, actually this is your GitHub account credential. So I can create this token for one day only, and now we can give access as per our requirements. So let's suppose that I'm giving full access to this. We will get a new token. This is now I'm also giving this token a full access to delete the repositories as well. So make sure that whenever you are creating token for your colleagues, for your employees, make sure to give them the only access that they need. Okay, since it is my own account, I am the sole owner, so I am giving myself full access, and then I will generate the token. Okay, it is saying that note for DevOps Molvi channel should not be blank. Now I will generate the token. Okay guys, make sure that you copy this token and paste it somewhere. I will temporarily save it in my no. Okay, I have saved it. Now I will use this token to authenticate from my VM. Okay, I will paste the authentication token here. Now let's see what is going to happen. Okay, so you can see that our Git protocol has been configured and we have logged in as Fasihan. So this is my account username. Now I can run this command to create the repository again. So GitHub repository, create a new repository or push an existing repository. Okay, now path to dot and DevOps repo description. This is my DevOps repo, and it would be our private repository, and add a remote. Yes, we have to add a remote like origin. Yes, origin. Would you like to push commits from the current branch to origin? I would say yes. And now let's see what does. Okay, so it is saying that pushed commits to this repository DevOps repo.git. So our every content, everything has been pushed to this repository. Now I will copy this URL and I will see what do we have on our GitHub account. So we must have this repository here. Okay guys, you can see we have this repository with all these files. That is something really cool while using GitHub CLI, and you can see that we have all the changes that we had on our VM. I mean, I have pushed the repository, I have pushed every file with all the changes. Now we will make more changes and we will create a new file to see that if our changes are being pushed on our GitHub repository. So you can see that all these files have their content. Now again, so this is wonderful guys. You must install GitHub CLI and you must authenticate with your token and create a repo and push the repo on your GitHub account. Now I will create another file. Touch, this is, oh sorry, my fourth file .txt. Okay, now git status, we can see that this file is untracked. Now I will, this is our fourth file and we are going to commit via git. Okay, and yes, git status, now it has been modified as well. So I will git add dot. Now again we will check git status. Now I will comment and git commit -m fourth file created, and you can see that one file was changed and one insertion. So I will use the git push command. This is a new command and this will push the changes to our master branch, and you can see that this file has been pushed. Now again I will refresh and see what do we have here. Okay guys, now you can see that we have this fourth file and it has been created, and so you can see this is our fourth file and we are going to commit via git. So here we can also get the comments. Okay, every commit that was made earlier with the commit ID here, and we can see all the changes here as well. This is just like we have git log. Okay, so we have all the commit here as well, and now we can also see all these comments here in graphical user interface, that is github.com. So guys, this is a little overview. Now again, I will, if I want to clone this repository, for instance I have another VM and I want to clone, I want to get the full copy of this private repository on my, let's suppose, another VM. So I can go here and I can paste this copy this URL and I will clone this. So for instance, this is my another VM and I want to get the full copy of that repository we have on our GitHub. So I can run git clone command and paste this URL, okay. I will copy it and I can paste git clone and this URL, and since it is a private repository and I have already been authenticated, now gh auth logout. Okay, I will log out from this account. Then again, if I want to clone this repository, for instance, I will remove this, remove DevOps repo, rm-fr DevOps repo. Let me remove it. Now again, if I run this git clone command, it will definitely ask for the authentication. Since we have logged out, so you can see that it is asking for the username. So I will paste my username, Pasi Khan, and I will use token as the password. Okay, now this would be my password or token. Okay, now you can see I can have this repository here, DevOps repo, and it should have all the contents here as well. So that's how we can clone the full copy of any GitHub repository. You can see it, this .git folder is here as well. So that was the practice, guys, in which we created a repository on our VM, and then we installed GitHub CLI, and we tasted a little bit of GitOps, Git operations. And so we have to create an account on our github.com. So I had my account, and then we authenticated using personal access token. Now let's see what can we create, how we can create a private repository here as well. So similarly, if I say DevOps repo 2, that would be the name, and this is our second DevOps repo, and then I can have it as private. If I have any sensitive or code or personal data or anything of my organization, so add a readme file about any information about the project. .git ignore is used to files which we do not want to track, which we do not want to be pushed to our GitHub account. So we can add those files, those directories in .git ignore, and we have to choose a license. It is for our personal use, so the license is none, and this will set the main as the default branch. Change the default name in your setting. We can change the settings as well, but let's suppose it is main, so we can create a repository using this option. So you can see our DevOps repo has been created, and now we can also for instance, if I change something here, let's clone this repo on our VM. Okay, and let's see how it goes. Okay, I will commit the change. That's how we can commit in. So our readme file has been updated. Now this is our main branch. Okay, and I will use the same this button, and we can have 3 types of cloned types. We can clone via SSH, via GitHub CLI, and also let's suppose I am using this option now because we have GitHub installed. So I will use this URL, and for instance, in our DevOps Molvi folder, I will use this, and now it says that run git auth login, and I will log in again and login with paste and authentication. So I have to paste the authentication again. Once logged in, I should not. Okay, now cloning into DevOps repo 2. So we have this DevOps repo 2 folder here, ls-l, you can see here, cd DevOps repo, and it should have only one readme file. And let's clone this repo on our VM. So that's how, guys, we can clone using GitHub Git operations, and this is the practice to clone repositories on your VM, and that's how we can create repositories on our GitHub account. So I think now that's enough for today's lecture. We learned how Git works. We saw the files being tracked and committed and in the stage phase. Also, we installed Git and GitHub CLI, and we created a local repository, and then we pushed that repository to on our GitHub account. Uh, that all that was all done practically. You saw that we also created a repository on our command line terminal, and you saw that we had this repository on our GitHub account, and then we also created a repository on our github.com. So I would strongly recommend that you must create an account on. I hope that you have that account on github.com, but if not, you must create one account on GitHub and try playing with Git and install GitHub CLI on your VM and push and pull changes to the repository. In the next chapter, we are going to discuss about Git branches and a little bit more about GitHub and Git. So make sure to subscribe my channel. I will watch you in the next lecture. Hey guys, I hope you're doing great today. This is our chapter number 21, in which we are going to talk about 30 important Git terminologies you must know as a DevOps engineer. Guys, in the last lecture, we covered how Git works. And now there are a couple of terms you must know as a DevOps engineer, because you are going to work with Git a lot in your day-to-day routine stuff. So these 30 important terminologies, I also wish that I have known them in the very first week of my DevOps journey. But since I don't want you to repeat such mistakes in your DevOps career, I thought that I should share these 30 important Git terminologies for your knowledge. And guys, it is really important to know these Git terms, because you can be asked in your interview about these Git questions. In one of my previous DevOps interviews, I was asked about 30% questions from Git. What is a Git repository? What is the difference between local and remote repository? What is the difference between Git fetch and Git Full Commands? So it is also from knowledge and interview point of views, you must know these Git terms. So let's get started and discuss each one of them one by one. So guys, the first is, what is a repository? A repository is a folder, a directory, which contains all the necessary files, code files, and your secrets, and so on. It contains a lot of data. It is your application's code, and each file and folder is actually tracked by Git. Therefore, the Git repository contains a hidden folder which is .git. And I have told you in my previous lecture that .git is usually considered as the database of Git, because it contains every information, every log, every commit, every branch. So we can say that Git repository contains everything, including your code, source code, and files, etc. And those files, folders, and that source code is tracked by Git, and that is collectively known as a repository. Now, the second term, what is the difference between local repository, local repo, versus remote repo? Now, you also must know the difference between these two terms. If I'm talking about local repository, what does this mean? If I'm talking about a remote repository, then what does that remote repository mean? And as the name says, that local repository means that the repository on your local VM, and that cannot be accessed by other developers. It can be worked on by you only, and it is on your local VM. And remote repository means that the repository or the Git directory on a remote location. The remote repository is always on a remote server, and that can be accessed by multiple developers, all the software engineers and coders, programmers in your team. So the difference is local repository, it is on your local VM, remote repository, the repository on a remote server. And that can be accessed by you only, and remote repository can be accessed by multiple developers. Okay guys, now third term is Git working directory. Git working directory. Guys, it is not like the normal directories we have on our Linux VM. For instance, we have multiple folders, multiple directories, but not all these directories are tracked by Git. Only the directory which is tracked by Git is known as a Git working directory, and it can contain your source code. So this directory is tracked by Git. Now what does tracked by Git means? Git tracking means that Git is always having a look on all the files. Git is monitoring them. Every time if there is a change, Git detects that change. For instance, if we have modified a file and then we checked in the previous lecture, we checked while running git status command, and Git told us that there has been some modification in that file. So that is actually Git tracking. Git always checks what is happening with your files, what is going on with your files, what are the changes happening with your files, and Git always tracks those changes. That is why it is a version control software. Now fourth term that is extensively used in Git is branch. In simple words, a branch is an isolated space for a developer. For instance, if we have this main repository and there are a lot of developers working on that code repository, and each developer can create his or her own branch and he can work on any specific folder, a specific feature. So branch A, B, C, D, E, F, and those branches are the different versions of the same repository. I can have the same content of the main repository in branch A. I can have it on B, C, D, and so on. So most of the times when developers are working on some features, they usually create a separate branch, and that feature is tested on that branch, and after the successful testing of that feature, any of these branches can be merged with the main or master branch. So for instance, if there are two developers on a single project and one is asked to integrate PayPal and the second is asked to integrate Stripe, both are payment solutions. So what do these developers will do? The developer A will create a separate branch for PayPal integration, and the developer B will create a separate branch for integration of Stripe. So that's how those branches, after their successful testing, can be merged with master branch. So that is why it is actually the practice to create different branches, and after the successful testing, those branches can be merged with the master branch. So in short, we can say that the branch is actually a different version of our main repository. Okay guys, now the fifth term is checkout. Now we know that there can be multiple branches in a single repository, and for instance, if I have three branches A, B, C, and I am at branch A, but I want to switch from branch A to branch C or from branch C to branch B, then I can use checkout, Git checkout, and it is used to switch between different branches. So if someone is talking about checkout, it means that he is talking about switching between the branch. I can switch from A to C, C to B using Git checkout. Okay guys, the sixth term is merge. Merge means to combine two branches. So if I have two branches A and B, I can merge both branches into another branch C, and that branch will have the code of A, it will have the code of B, and we will collectively get the files and code of both branches in another new branch C. Or we can also merge the changes of these branches into our master branch as well. So when developers are working on some features, they create branches, and when that feature is successfully tested, the final code or that branch is actually merged with the main or master branch. So merge means combining one or more branches. The seventh term is pull. You can take the pull of that branch. What does this mean? If some developer asks you, you can take the pull from branch ABC. It means that you can bring out the changes of branch ABC on your local VM. So pulling means to get changes from a remote repository on your local repository. For instance, we have this repository. It is a local repository, and we have this as a remote repository on a remote location, remote repository, and it has some changes, okay, and I want all those changes on my local repository. How can I get all these changes on my local repository? I will use git pull, and I will have all these changes on my local repository. Okay, so pull means that to get the changes from a remote repo on my local repository. We will use git pull command. Okay guys, the eighth is actually the opposite of pull, which is git push. So if I'm talking about pushing some changes, now it is the vice versa of git pull, and in git push I am going to push my changes from my local repository to the remote repository. So the difference is, you can be asked about the difference between git pull and git push commands. So git pull means pulling the changes from a remote repository to the local repository, and pushing means, git push means push the changes from your local repository to the remote repository. Okay guys, the ninth term is status. Status means what is the current status of any repository. If there are any untracked files, if there are any comments, if there are any files in the staging phase. So status tells us everything we have, and in the previous lecture we saw if we are modifying any files, we can run git status to see which files have been modified and what modifications have been done with these files. So the 10th term is clone. What does clone mean? Clone means to bring the whole remote repository on your local VM. We can use git clone command, and we can use the repository URL to bring everything in that repository on our local VM. So by clone means that we can copy the full remote repository on our local VM. So git clone works like git clone and the repo URL, and then we will have all the contents, everything in that repository on our local VM, on our server. So the 11th term is cherry pick. Cherry picking means that if I have any change or comment in my branch A, and I want to have the same comment, same change on branch B at the same time, then I can use cherry pick. Cherry pick will only copy that comment from one branch to another branch. And also cherry pick can be used to undo changes. For instance, you were writing the code and you pushed and commit that code, but you want to undo that code, that piece of code, because it is creating some errors. You can use cherry pick command to undo that changes. And guys, this is one of the most important interview question, that what do you mean by cherry picking in Git? So cherry picking means to copy the comment, to copy one thing from one branch to another branch at the same time. And can also be used to undo some changes in one branch. Okay guys, the 12th term is fork. A fork is a copy of a repository that is on a remote server. And why fork is used? For instance, if I have this main repository, this is my repo, okay, and it can be on GitHub, but I want to do some changes in the code. So what would be the best practice? The practice is to fork, to take the fork of that repository. So fork is actually the copy of your main repository, and after that you can make changes in that repository, and after testing those changes you can then push the changes to the main repository. The 13th term is fetch. And as the name says, git fetch is also used to bring the changes from a remote repository to your local repository. So what is the difference between git fetch and git pull? The main difference is copying the files. When we use git pull not only fetches the changes, but also it copies all the changes in our local repository. So it means that when we use git pull, the changes, everything with that remote repository are copied into our local repository. Whereas using git fetch, we just know about the changes in a remote repository, but those changes are not copied in our local repository. So that is actually the key difference. Git pull not only tells us the changes happening with our remote repository, but also copies them on our local repository, whereas git fetch only tells us the changes with our remote repository, and those changes are not copied into our local repository. So that is actually the key difference between git fetch and git pull. Okay fellas, the 14th is head. Your head is actually your default branch, and most of the time the head is master branch. But whenever we switch from one branch to another branch, that head is also updated, and it points to the current branch, and it points to the new branch. For instance, I'm at branch A, so it means that my head is pointing to branch A, and now I have switched my branch A to B, so it means that the head will be pointed from branch A to branch B. So whenever we switch from one branch to another branch, the head is also updated and it points to the new branch. And also the other definition of head is, it is the symbolic reference of any commit, and it is used to refer to the current commit. So in our Git Commands lecture, we will actually practically see if we check out, if we switch from one branch to another branch, the head gets changed, and we will see how that head points from one branch to another branch. The 15th term is index. In Git, index means the temporary staging area, and Git index is used to prepare the changes before committing them into the project history. So let me share it with an example to understand index more. When we run git add command, for instance, we run git add and dot to add the changes, it means that those changes are not added into the repository. Those changes are saved in some point which is known as index. And after that, we definitely run git commit command to commit all the changes into the repository. So when we run git add, those changes are saved in a cache which is known as index. The 16th term is easy, and it is master and main branch. So if someone asks you what is master or main branch, you can tell them it is actually the default branch of our Git repository. It can be master branch, it can be main branch, and not everyone has the access to this branch. And when some features are tested on other branches, those branches can be merged with the master or the main branch. So it means that it is the primary branch of our Git repository. The 17th term is origin. Origin means the repository URL. So most of the times origin means the remote repository URL. We are getting some changes from a remote URL, remote repo, and that remote repo URL can be considered as the origin. In other words, the origin is the shorthand name for a remote repository from where we have cloned the project. So it is the shorthand name of our remote repository, and it is known as origin. Okay guys, the 19th term is pull request, or commonly known as PR, generate a PR. So pull request is actually a request to merge the changes from one branch to another branch. Okay, so for instance, if I have been working on a project and this is my branch A and this is my branch main branch, which is our primary branch, and my changes have been done, I have tested the code and everything is verified. So now I want to merge the changes in that branch into the main branch, and I don't have access to the main branch. So what I will do is to initiate a PR, which is commonly known as pull request, and then the person who has the access to that main branch will accept this pull request and the branch will be merged. So the changes in that branch will be copied into the main branch. So guys, let me repeat it. Whenever we are going to test some functionalities, or whenever a new feature is going to be introduced, that feature is actually worked and developed in a separate branch. Master or main branch are never touched because these are the primary branches which have the final code, and everyone does not have the access to the main or master branch except the development manager. And when any feature is tested on any branch, that developer will initiate a PR or pull request, and the development manager will review the code, will test the functionality, and he will get the feedback. And when that pull request is accepted, the changes are merged from one branch into the main branch. I hope that now this concept is clear. It is one of the most frequently used terms to create a pull request, PR. Okay guys, the 20th term is rebase. What is rebase? Rebase, it is a command actually, git rebase, and with the help of this command we can actually modify the history of our git commits. Since the developers are working on some repository and they're writing code and committing that code to a repository, we can modify, we can change those commits using the git rebase command. So let me explain git stash with the scenario. I have this repository, okay, repo, and I have two branches in this repository. This is my branch ABC and this is my branch XYZ. I was working on branch ABC, but due to some emergency I have to switch to branch XYZ to finish up something. But I do not want to commit the changes on my branch ABC, so I can use git stash and those changes will not be committed, and I can switch from ABC to XYZ, and after finishing the work on XYZ branch I can come back on the branch ABC to finish up my changes, and then I can commit. So let me repeat it. I have two branches, ABC and XYZ, in the same repository. I was working on ABC, but due to some urgent task, I have to switch to branch XYZ. But I do not want to commit the changes that I have been working on branch ABC. I want to leave those changes uncommitted, and then I can use git stash, and those changes would be saved but not in the commit state, and I can finish up my emergency task on XYZ branch, and then I can come back to branch ABC and finish that work and then commit those changes. The term is revert, and since from the name revert means to reverse the changes, and in Git revert means to revert the commits. I have already pushed that commit, but I want to revert it. I can use git revert to revert that commit. In Git, reset means to reset everything, including your working directory, your branch, your head. Everything is reset when we use git reset. And if we are not able to reset, we can use git reset hard. So it will forcefully reset the head, the changes, the working tree, reset hard. The 24th term is git ignore. For instance, this is my remote repository and I'm working on my VM. This is my local repository, local repo, and it contains a number of folders, folder A, B, and C, directories. I don't want these directories to be pushed to my remote repository. So I can add those directories that I don't want to be pushed in .git ignore. This is actually a hidden file and it contains the files, the folders, the log files that we do not want to be pushed to our remote repository. I can simply add those files or directories here in that format, ABC and file name, etc. So Git will check the .ignore file and all the folders and files mentioned in this file will not be pushed to our remote repository. The 24th term is gist, G-I-S-T, not Git, it is gist, and it is a utility by GitHub to share the code snippets with the developers. The 25th term is diff. So diff stands for difference, and in Git, diff means to see and compare the changes in your code. In our previous lecture, you saw that I have one file and I have made first change. This was my first change, okay? And I didn't commit the file. Then I modified again and I inserted the second change. And then after that, I checked with git diff command, and git diff told us that your file has been modified and there are that many number of insertions in that file. So git diff actually compares the changes in your code and tells you which files have been modified or changed. So the 26th term is blame, and in Git, blame means to show who modified any file for the last time. We can use git blame, and we can mention the file name who was changed by whom. So blame is actually used for troubleshooting, and it also identifies the person who was working on a specific file. So 27th term is git log. For instance, if I want to see the logs of all the previous commits and who committed those changes, I can use git log to see the commits history. So git log is actually a wonderful Git command to see the commits, logs, and history. Guys, Git hooks are actually the Git scripts. In .git folder, we have a number of directories like log, like info, and we also have hooks. There is a hooks directory which contains some scripts. So if we want to automate any tasks in Git, we can use Git hooks. The scripts are copied in hooks directory, and when there is any change in that repository, those scripts are automatically triggered. So if we want to automate anything in our Git repository, we can create scripts and place them in the hooks directory. The second last term is Git LFS, large file storage. So Git LFS is actually a utility to manage the large files. For instance, in our code, we can have large video files, audio files, or large data sets. So Git LFS actually manages all those large files separately. So we can say that Git LFS is actually a Git extension that is only designed to manage the large files in our code base. So our last term is personal access tokens. So for instance, we are going to clone any remote repository on our local VM, we definitely have to use the personal access token. So personal access token plays the role of a password. You can create customized personal access token. You can grant the limited permissions on any personal access token using github.com developer settings. So when we modify any changes in our code and we want to push them in our remote repository, which can be hosted on GitHub, we can use personal access token for authentication. You can watch my previous lecture in which we created a personal access token and how we used that personal access token to authenticate with a repository on GitHub. Alright fellas, I hope that you have got a lot of concepts cleared regarding different and important Git terms like Git rebase, Git init, Git repository, remote repository, origin, head, and so on. However, I will create a different Git interview questions and answers video, but you guys can consider these 30 Git terms as 30 interview questions. As a DevOps engineer, you must know what do these terms mean. So make sure to watch this full lecture, and still if you have any questions, please leave them in the comments and I will definitely answer those questions. And make sure to subscribe my channel DevOps Molvi on YouTube. I will watch you in the next video. Hey guys, I hope you're doing great today. This is our chapter number 22 in which we are going to discuss about what is a Git branch. Guys, that would be a little tiny mini Git course in which we have covered 3 chapters already. The first chapter was about what is Git, and the second chapter was how Git works, and the third chapter was the 30 important Git terminologies you must know as a DevOps engineer. So now we have the basics cleared about Git, how Git works, and the 30 important terminologies like Git rebase, Git merge, Git clone, cherry pick, Git pull, Git push, branches, etc. What do we mean by Git pull? What do we mean by origin, commit, etc.? So these 30 important terminologies that you must know as a DevOps engineer. And there was one of the terminology I have given a brief overview since we have to cover the other Git terminologies. It was Git branch. So I thought that I should prepare and give a full-fledged lecture on Git branches. So the wait is over and today we are going to talk about Git branches. So let's get started. So guys, if you are asked to define Git branch, what is the simplest definition of Git branch? So the simplest definition of a Git branch is that it is a copy of your main repository. It is a working copy of your main repository. So you can or I can create as many copies as I want. The other definition is that a branch is an independent line of development. A branch is an independent line of development. For instance, if I have this main project with main as the main branch. Now if I want to create branch A, I want to create branch B or C and so on, then if all the branches are created from the main branch, then they will have the every content of the main branch in each A, B and C branch. So we can say that each branch is the copy of the main repository. But the question is, why should we create a new branch every time? though we have our working code in our main branch, or we can say it a master branch. Main and master branches are almost the same, just a difference in the naming convention. So why I'm creating the branch A? Why do we have to create the branch B or C or any other branch? And the main reason is whether we have to work on a new feature, or we have to work or fix any bug in our code, whether it is a small feature or a small bug, or whether it is a large feature or a large bug in our code, in our repository, we have to spawn or we have to create a new branch every time. And when that branch is created, we can fix our bug, we can create our new feature, and we can encapsulate our changes in that new branch. So my fellas, this is not at all recommended practice to work directly on the main branch. This is actually the stable code, the working code, and we never have to touch the code in our main or master branch. Every time I have to work on some new feature, or every time I have to fix a bug, I will create a new separate branch. Okay, now for instance, I have created that branch and I have fixed the bug and my feature is ready, or my bug has been fixed. Now what? For instance, I was working on some feature in branch A and my feature has been ready and it has been tested. So after that, when that feature is ready, the code of that branch is actually merged into the main branch. So that is how development works. For new features, for bug fixes, we created multiple branches, and after the successful testing, those branches or the code is merged with the main and master branch. So the code on the main and master branches is never touched. It is the final and fully functional code we have on main or master branches. So guys, for instance, this is our main project tree. So this is our project tree and this is our main branch. Every time I have to create or work on a new feature, I will create a new feature branch. This is my feature. So I thought I should share it graphically. And for instance, this is some feature 1, and for feature 2, I will create a new another branch. For instance, this is a small feature and this is a large feature. Every time this is the separate branch and this is separate, and when the code is tested on these branches, it is finally merged into the main branch. So guys, you can see that main is an independent branch. We never directly work on the main branch and we never touch the code on our main branch. So every time I have to work on a new feature, I will definitely create a new separate branch. So that is actually the graphical representation of how we should create branches, and this is actually the recommended practice to create a separate branch for your features, and when the code is properly tested, that code is merged into the main branch. So that is actually the core branching strategy you must know. Another feature of creating branches is, for instance, this is my project. Now you can see that multiple features are being developed in parallel using branches. So that is also one of the biggest advantages or benefits of creating branches, that we can work on multiple features at the same time. If we have to fix a bug, I can create a new branch. So multiple features, multiple bugs are fixed and created at the same time in parallel using branches. Alright guys, now let's talk about some branch naming conventions in professional organization, and we will actually check on open source Git repositories and how their branch naming convention. So normally it is the practice to create branch namings like we have QA, we have dev and prod, and now after that this is actually the branch naming convention 1, 2, 3, 4, and that's how we create branches. And for releases, this is actually the proper format that how we should create release branches at 1.0.1, 2, 3, 4, and that's how we proceed further and we start creating branches. And there should be a separate branching for features. This is for releases, this is for features, and similarly we can create for hot fixing bugs like bug 1.0.1, and that's how we can create branches. So normally this is the practice to create branches, and developers create branch and then they start working. And also we should keep in mind that some branches are team specific. On a single project there are definitely a QA team is also working on that project, development team, software engineering team, front end team, back end team. So these are actually to differentiate that this branch is related with the QA team. So another example that was observed in one of my last companies is that for backend it was like 1.1.1 etc. So for front end, and that was all for the same project, and all these branches for one repository. And backend team was creating branches like this. I mean, that was their naming convention. And for front end team, the branching names were started with front end, and that's how the branch number. And for QA, dev, prod, and also there were branches for features. For final releases they were using release when that code is properly tested and we have a new release to be released, and that was actually with release. And if there is any bug in the code and that has to be fixed by the development team, so the branch was created with bug 1.0.1, 2, 3, 4, 5, 6, and so on. So guys, this is actually the professional way, and you can say that this should be the branching strategy to create branches that are concerned with the respective team. And also it makes it simpler that, for instance, if this is a backend branch, then it must be worked on by the backend team. All this is being handled on a single project. And by the way guys, we can add collaborators on a single branch from multiple teams. For instance, if there is an issue on any front end, for instance, branch, then we can have developers from the backend team, from the QA team, and we can add them as collaborators on this front end branch. So that is actually happening in any project, software development project. We can add multiple branches, we can add multiple collaborators, and this branching strategy makes it easier, makes it simpler to understand that who is working on which branch. And this is not for a tiny project, this is actually a large project where there are hundreds of developers, backend, front end, and full stack developers, and also QA team members are working on a single project. Then these naming strategies, branching strategies make it easy to track the issues and to boost the project performance. Alright fellas, it is time for our lab session in which we are going to play with Git branches. Alright guys, this is my repository that we created in our second lecture, how Git works. And you saw that we created a couple of files just to play with how Git works. So first of all, we have only one branch on this Git repository. This is my local repository. DevOps repo is my actually local repository, but we pushed this repository to GitHub as well. And now this is our remote repository. Okay, the repository on my VM is local repository, and now this is the same DevOps repository. It is my remote repository on GitHub. So you can see that I have only this one master branch, and we can check it here as well. Git branch. So there is only one branch, and it is on master. This status actually points where your which is your actual branch right now. So I am at master branch, and we will see how we check out, and this status point to a new other branch. So git status, we can see that our working tree is clean and our branch is up to date with origin master. So the git status is showing that we are on master branch, and also from git branch we know that our branch is master, and our working tree is clean. There is nothing to commit. So all these files are actually in the master branch. Okay, these are actually in master branch. Now let's create our first branch. For instance, git branch and the branch name. This command will create a new branch. For instance, this is my new feature one branch. I'm creating this new branch. So the command is git branch and the branch name. Git branch and your branch name, and we will have a new branch created. So git branch, and now you can see that we have actually two branches. Okay, and similarly, if I want to create a new branch, again feature 2, then we can see git branch dash hyphen hyphen list will actually also list down all the branches, or we just simply run git branch to know how many branches do we have. So similarly, if I create a new branch bug 1.0 and git branch release hyphen 1.0.1, so we can see now we have a lot of branches, but our pointer, it means that we are still pointed at our master branch, and the status is mean that you're actually at master branch. So in order to switch among different branches, we can use git checkout command. So for instance, if I want to switch to release 1.01, I'm going to work on some project. Okay, then I can run git checkout command and the branch name. Okay, git checkout branch name, and you can see we have switched to branch release point this 1.0.1. Now our status or pointer must be pointed towards release. Git status, and we can see that we are already on branch 1.0.1, and git branch will also let us know, it will also tell us that your pointer is pointed towards this branch. So guys, that's how we can switch among different branches. But there are no commits in this branch. It is a branch, it is a brand new branch. You saw that I just created, and there must be nothing in this branch. We can see there is nothing to commit. Working tree is clean. Now I can use git checkout to switch from this branch to feature 1. This is just practice, guys. You can see we are just practicing how we can switch among different branches. Now we can check git status. We are now on feature 1, and also git branch also shows that our point is pointing, status is pointing towards feature 1. So that's how we can switch among different branches. So you saw that we had only one master branch on this repository, and then we created around 3 or 4 different branches: feature branch, release branch, bug branch. Then we switched among different branches. I switched from master to release, then from release to feature, and from feature to bug. That's how we can use git checkout command to switch among different branches. Now there is one important thing that I want to let you know, that still we have only one master branch here. We don't have other branches. You saw, I if I click on view all branches, I have only one master branch. So I have to use a new command to push these branches to my GitHub, to my remote repository. These branches are actually created on my local repository. Now I want to switch all these branches to my remote origin. So my remote repository is this one. Okay, I have this is my actually remote repository on GitHub. So I have to push all these branches to my remote repository. Then I would have to use a different command to push these branches to my remote repository. We have all these branches on our local repository. So now guys, let me show you something really interesting. You saw that we have these branches on our local repository, but we do not have these branches here on our remote repository, and therefore I want to push all these branches here on our remote repository. I can use the git push command, but this is not the full command that we can use. We will use this command, git push set upstream origin feature 1. Now since I am at feature 1 branch and I want to push this branch from my local repository to my remote repository. Remote repository is my DevOps repo on GitHub. So I will run this command, and it will definitely ask for our token. So guys, you can see that I'm now again logging with my token. I was logged out, and now I will use the git push this command set upstream. Now you can see that I have pushed this feature 1 branch to my remote repository, and now we must see this branch here on our branches list in our GitHub account. So you can see we have this feature 1 branch and it is active. So now again, if I go to the code option, and I must see now 2 branches here. So feature 1 had recent pushes 58 seconds ago, and now you can see we have these 2 branches. Similarly, I want to now, for instance, git branch, and now I will check git status, and I am already on feature 1 branch. Now I will switch to git branch, git checkout release this branch. Now I am at release 1.01 this branch. Now I will use this command to push my release branch to my remote repository. So I will just need to have the token. Make sure that you watch my previous lecture how Git works. Now guys, you can see that I must have another branch. Each branch has the content of master branch. Now again, for practice, if I am at now release branch, now git state git branch, and now I want to switch to bug 1.0 branch, git checkout this branch. Now git status, I want to push this branch to my remote repository. Now I can push using this command set upstream origin. This is actually the command to push our local branches from our local repository to our remote repository. Now we can refresh again to see if we have all these branches that we created on our local repository on our remote repository. You can see that I must have these branches. So for instance, I have now this branch. So this branch is also up to date with master. Now in total, I have 4 branches here. So guys, if I want to delete any branch, for instance, I want to delete the feature 1 branch, simply click on this trash button and the branch will be deleted. You can see it is deleted. Now let me refresh again. So we must have this branch deleted. Now you can see that we have this branch feature 1 has been deleted, and if I check on code, we should not find this branch anymore. So we have now only 3 branches. So that's how we can delete any branch from our remote repository. In order to remove this branch still exists on our local repository. And now for instance, if I want to remove or delete this branch from here, then I can use git branch minus d, capital D, and feature 1. So that's how we can delete any specific branch. And the command is git branch with capital D. For instance, if I want to rename this feature 2 branch, then I can use this command git branch minus m and feature 1 to feature 111. Now I can check git branch and you can see our feature 2 branch has been renamed to feature 111. So git branch minus m is the command to rename the branch name. For instance, this is bug 1.0. I can rename it to git branch minus m and this your current branch name and your new branch name. So we can run git branch, then we can see that this has been renamed as well. So again, if I want to remove or delete, this is just for practice, git branch minus capital D and the branch name, it will delete the branch. Now I can check and these branches have been deleted. Now guys, we have these branches. Okay, now I want to merge this branch and this release branch and bug branches into master. So I have these 2 branches, bug branch and release branch, and now I want to merge these branches into master. So what is the practice how we can merge 2 branches into master? I can go in git checkout master and then I can use git merge. Since I am merging bug and release branch into master, so I can use git merge command, then branch this and release 1.01 this. So it is saying that the master branch is already up to date. So let us change something in git branch, git status. I'm at master branch. Now I will use git checkout and I will create a new file, touch new file dot t and nano new file. I will create some changes. The changes have been done. Now I can check git status and I will commit this. It would be committed into this branch. Okay, now this branch would be ahead, one commit would be ahead from our master branch. And I'm just fixing some error on this branch, let us suppose, and git add and git commit minus m testing merge. So now I will check the git status and it is working clean. Now I can switch to git checkout master and git status. Okay, we are on our master branch. Now I want to merge these two branches, git branch bug 1 point this, git merge this our first branch, and git merge the second branch. Now you can see that we have our new file .test, and it has some 5 insertions, and that's how we have merged one branch and the second branch into the master branch. We can merge one single branch. Now again, let us do this for practice. Git checkout and this branch. Okay, now I will create again a new file. So something is happening on release branch. Nano new again file.txt and change. I have made this change. Okay, and git push. Let us push this to release 1.01 branch. So git add this, git commit -m new change, and now I will push it to the release 1.01 branch. So you saw that I have pushed the changes in my release branch. Now if I refresh, you can see that release branch had some recent pushes out, and now this branch is ahead, one commit ahead of master branch. Now I want to merge this release branch with my master branch, so I can use I will first check where I am. I am at release. Now I will git checkout master. Okay, now I'm at master, git status. Now I will use git merge and the branch name. So it will merge release 1.01 into master branch. So I have merged this branch release into master branch. Hi fellas, I hope you're doing great today. Today we are going to discuss the 50 Git commands you must know as a DevOps engineer. But first of all, I would like you to please make sure to subscribe my channel on YouTube. You can see that we have been working together. It's not me alone, you're also working with me, and we have covered the basics of Linux. We have covered a full course. You can find it on DevOps Molvi channel. We have also covered the basics of Docker as well. So I have created this DevOps full course playlist, and we are on chapter number 23 today, and we have covered 22 chapters in total so far. And also we have this Docker to Your Minds playlist, in which you are going to find all the basic chapters of Docker. We have Docker volumes and Docker deep dive for networking. We have Docker 50 commands as well, and this is for Linux basic tutorials. And also I am trying to create short videos for important DevOps interview questions. So make sure that you subscribe my channel on YouTube. So let's get back to work and let's start our first Git command. So guys, I have tried to select the most important and most frequently used Git commands. So let's start with our first command, and it is git help. So git help shares a couple of important Git commands, and you can take help using git help. And you can see that we have clone what does clone mean? Clone a repository into a new directory. Git init, that would be our second command. And what does it do? It creates an empty Git repository. So if you are facing with any issues with any command, you can run git help and that command. For instance, I run git help sorry git help repo uh, init, and now you can see a complete tutorial, a complete git manual to find all the details about the git init command. Okay, and now you can see we have these options, we have everything, a deep insight into each command. So you can run git help command to get the help regarding any git command. Okay guys, so let's start our for second command. So git help is our git command to know and to get the help regarding any git command. So git version is also another command to know the version of git installed on our system, you can see. And now the third command is, first of all, let's create a directory, DevOps repo. Okay, I have created this directory and I will go inside this directory and git init. This is our third command, and it is used to initialize any empty git directory. Now first of all I run ls-la, and you can see that there are no hidden directories and there are no other folders or files in this directory. So it is a brand new empty directory. Okay, ls-la shows the hidden files and folders as well, you know that. Now I run git init command to initialize an empty repository on my local VM. This command actually initializes an empty local repository on my VM. Now you can see that it is saying using master as the name for the initial branch. So we have master as our initial branch. So there can be only two names, either it is master or it is main. So master and main branches are the primary branches of Git repository. Now you can see I have this branch as master. Okay, git status is the command which shows on which branch we are currently at. Okay, now you can see we are at on branch master or on branch main or on branch release 1234. So git status actually tells us the current status. It also shows the untracked files, the staged files, or the files that need to be committed. So we have used git init to initialize an empty repository on our VM. Now it has initialized, and you can see it is saying initialized empty git repository in home, this folder, my repository folder, and .git. Now there should be an empty and a hidden .git folder. Now you can see it, and guys, it is actually the database of Git. Normally, if you want to understand, you can simply say that it is it is a database. It is the database of our Git repository because it contains everything regarding our repository: branches, config, hooks, objects, references, and it contains everything, comments, information. So we can say, just to understand, we can say that this is a database of our repository, a Git repository. So now we have initialized, you can see, and we have now git status. We are on branch master. if I want to clone a repository, and I have this repository link, for instance, and this is my public repository, and I want to clone it, so I can use this URL clone using the web URL. Okay, and I will use git clone and the repository URL. Now you can see we have downloaded the full repository from our GitHub on to our local VM. So git clone actually downloads the whole repository with each and every file. So git clone is a very wonderful and fantastic command which downloads the full repository into a folder. Now I must have this sharks node cd. This is the folder that I have cloned. This is a repository actually, and now you can see I have all the files, all the Jenkins files, Docker file, dioscript.sh, which we have here on our, you can see dioscript, we have Docker file, Jenkins file, package.json, .git folder, everything we have here. And I have used git clone command. And guys, this is also one of the important interview question, that what is the difference between downloading a file from GitHub and what is git clone. So git download, if I download any file separately, it will just download that file, it will just download that folder. But if I use git clone command with repository URL, git clone repository URL, then it fetches the heads, it fetches all the branches, and it completely downloads all the contents of that repository on our local VM. Now I can see the branch, and I can see all the branches. If there are any other branches, git branch -a is the command, and you can see it is on our main branch. So git clone is actually a beautiful command to clone, to download all the contents of a repository on our local VM. Okay guys, now back to our empty initialized repository, which you can see that I do not have anything. Now I will run git, I will create an empty file, nano first file.txt. Okay, I can, this is our first file, and I will just save it. Now I can see git status, and you can see there is an untracked file. How git works, I have a full lecture to know that how actually git works, how, what is the meaning of untracked file, what do you mean by stage file, what do you mean by commit files, so what is a commit. So I have this second lecture, and I will definitely share the URL of that video in the description, so you can find it how git works. So now you can see I have this untracked file, and now I will add it into, since it is untracked and I want git to track it, so I will add it, git add, and that file name, or I can use dot as well. So dot will add all the files in the current working directory, and I will use this to add this file. Now I will check the status. You can see it has been changed. The untracked file was having the red color, that is, the color combination also gets changed, and now this is in the staging phase, stage file, and the color is green. Now I will commit it, and the command is git commit -m, and your message, this is my first file, and okay, git commit, and the file would be committed, and -m actually stands for message. What is the commit message? And I will now, this file has been changed, one file changed, and there were 3 insertions. Now I can see the git status and it should be clean. So I am on master branch. I added one file and I have committed this file into the repository. Now whatever change, for instance, if I change this file, then our git will tell us that this file has been changed. Nano first file, and this is second change. And now again, git status, you can see the file status has been changed. Again, I will run, and now guys, I can run git diff command to differentiate. Okay, git diff command, and you can see that there is a difference between the first version of the file, and now this is actually the change that needs to be committed. So git diff is also a beautiful command to differentiate the previous and the current version of a file. Now you can see git status. We have 2 files. In first file we have 2 lines, 2 changes. This was our first change, and now this is our second change. So when I have changed this file, you saw that the file status has been changed from commit to untracked. Now I can again add this, and git commit -m. This is my second change, and now git status, and our working tree is clean. Now there should be no difference. Git diff command, and it is not showing any difference. So git diff command helps you compare, and it tells you the changes in your project. Now for instance, if I let us repeat quickly, if I create another change, and this is my third change. Okay, this is my third change. Now if I run git diff command, it would definitely show that there are some changes in the file. Okay, now which change? This is the change. This is my third change. So it means that I have to update my project, I have to update my repository, and if this change is valid, I would definitely commit it. And git add this, git add git commit -m third change. Okay, message. Now I can see the git log. The git log is also a command to show all the logs of the commits. Now I can see this is the commit log, and if I want to see the recent commit only, then I can use git log -1, and it will show us only one last commit. For instance, nano first file, and if I this is my fourth change, and I will just git add git commit -m fourth change. Now if I run git log -1, you can see our commit has been changed. And if I want to see the last 2 commits, then I can run this. If I want to see the last 3 commits, then I can. So -3 will and definitely -5 will show us the last 5 commits, -10 will show us the last 10 commits. So this is actually the commit history, you can say, or the commit logs. And also you can see this as author and email. Now we can change the author as well. What is the command to change the author? Git config user dot name, and now it is DevOps guy, and I I would just replace it DevOps fella. Okay, so now the user name has been changed. Now for the next commit, the changes would reflect. Okay, you can see now I have this DevOps guy. Now it should be as DevOps fella. So let us change the file nano first file, and this is my fifth change, and I will git add git commit -m fifth change, and now you can see the git log. Now I will see the git log -1, and the author should be DevOps fella. So we can change with git config user dot name. Now similarly, in order to change the email, this is abc@gmail.com. Now I will change user email user dot name, and I can now use user dot email and DevOps fella at gmail.com. Okay, this is the user email. Now again, git nano and first file, this is my sixth change, so that we can see if our email has been changed as well, and git add git commit -m sixth change, and now I can see git log -1, and it has been changed to DevOps fella at gmail.com. Now this author will have the this all the comments by this user will have author as DevOps fella and email at as DevOps and gmail.com. So for large organizations where are hundreds of developers are working, they must have their authors and they must have their separate email addresses, so that we can know who is making that comment. So that's why author and email address are required. And if I want to have a global author and a global email, then I can have user.name. For all the comments, I just want to have only one user, global, and DevOps girl. This is my user.name, global username, and now git config global user dot email as devopsgirl at gmail.com. So now using git config global user dot name, then it will show us that DevOps girl is our global username. And also if I want to see if our email has been changed as well, so you can also run this command to know that this is our global email. So this is our global username and this is our global email. So that's how, guys, we can change the username, the author name, and that's how we can also change the global user email. So these commands are used to set the user and emails. We know that git log -2 or -3, we can see the last comments. Okay, now if I want to see them in one line, then I can use git log -1 line. Now you can see the difference. This is the comment in different spaces. Now you can see the difference. We have these comments and with spaces, and now there is only one line comment, and we don't have the author and the other date details. Just we have only one line comment with the comment ID. This is the comment ID. Now git log -1 line, so it will show us the only first line of the comment. Okay, git log minus minus one line, and you can see the difference. Now if I run git log, then there is the full detail of the comments, okay, with author, with date, and with the comment message. And now you can press colon and q, okay, just press q and it will exit. So I can see all these comments in one line. The first line of the comments, git log hyphen hyphen one line. Now you can see we have only the change, the only comment change, and we can see it this with this command. But if you want to see the details of all the comments, then we can definitely run the git log minus one or minus two command. And git log minus minus one line only shows us one line comment message and what is the comment message. So this is also a beautiful command, and it actually shrinks the details and you just get the comment message. Okay guys, now we have this 7th change comment and 6th change comment. So if I want to see the difference between each comment, now I can run git log minus p, okay, then I can see the details of the differences between the comments. For instance, let me run it again, git log minus p. Now we have the 7th change and we have the 6th change. So if I want to see what were the changes in the file, this file, first file .txt, and this was the 7th change. And what was the 7th change? Here it is the 7th change. And now similarly, if I want to see the difference between the 7th change and the 6th change, so we can see the difference of comment 1 and comment 2. We can see the differences between the comments using comment log minus p command. Now for instance, if I change, for instance, this is my file nano first file. Now I want to create a big change. I will just empty this file. Okay, now better understand it. Then git add git comment minus m 8th, or I can say final change. Let's suppose it is my final change, in which you can see all the changes were deleted, 11 deletions, and one file has been changed. Now git log minus p, you can see this was the 7th change, but in the final change all the content of the file was deleted. So that's how we compare the second last and last commit. That's how we can compare the commits, all the commits at one time as well. Now it is a huge detail, and we can see the difference between first and the second commit, second and the third commit, and so on. I hope that now you have understood this. And now again, nano first file and 9th change, and git add git comment minus m, this is my 9th change, to see the commit difference. Okay, now git log minus 1, this is my 9th change. Okay, now git log minus p, so it will compare the 8th commit and the 9th commit, and also the 7th commit and the 8th commit, and 6th commit and the 7th commit. So each commit is actually, you can see this is my 9th change, and in 9th change what was done, there was some change in the file, and you can see the 8th change, in which all the files, all the contents of the file was deleted. So if I want to compare the commits difference, I can run this command git log minus p and q. Now guys, if I want to see which file was changed, though I have only one file, but still git log minus minus stats, sorry, stat, and now I can see that only this is only one file that has been modified, this file only, this file only. So git log minus minus hyphen hyphen stat shows us which file was modified for the last time. Okay, so this is also the command. So all these commands are related with the logs, with commits history, and these are also wonderful commands for troubleshooting Git issues as well. And for instance, if I want to now I want to see which the author of the last comment. For instance, I have this author and I want to see all the comments from this author, then I can run git log minus minus author is equal to this. Okay, now I have this DevOps fella author and I can see all the comments, though I have only this author. And for instance, and I can see all the commits from this author. So the command is actually git log minus minus author is equal to DevOps girl. There are no comments from this author. Git log minus minus hyphen hyphen author is equal to ABCDEF. Now I cannot see any comments from this author, but if I run the name of the actual author is equal to DevOps fella, then I can see the comments from this author. Okay, if I want to find this commit message, okay, then I can run the command as git log hyphen hyphen grab is equal to the comment message. I do not want to paste the full message. I would just paste the first word, and now you can see the full message. For instance, if I want to grab this comment, ninth change, and I will just paste git log hyphen hyphen grab is equal to ninth, then you can see that this full commit is printed and we can see the full message. Now guys, you can see that we have all these comments and I want to see them in a graphical way or in a decorated way. Then I can run git log minus minus graph hyphen hyphen decorate. Now you can see the comments have been decorated, and you can see the stars and their links with each comment. So git log hyphen hyphen, and it is a good command to see the tree, to see the difference. Git log hyphen hyphen graph, then I can see the graph and the comment in the form of these stars. And also if I want to see git log hyphen hyphen graph hyphen hyphen decorate, and I can see the comments and in a graphical representation. So this command is used. Now guys, for instance, git log -1, this is my last comment and I want to change this comment message. Then I can use git commit or hyphen hyphen amend command. Now I can change this comment. For instance, it was my 10th change and I mistakenly wrote 9th change. Then I can use this command and I can see the commit git log -1, and I have the commit as this is my 10th change. Okay, for instance, it was my 11th change. Then I can use git commit hyphen hyphen amend. Okay, amend means to change the commit message. This was my 11th change, and I can now save it. So my commit message has been changed, git log -1. Then you can see that this is my 11th change. So guys, that's how we can commit, we can amend, or we can change the last commit using git commit hyphen amend command. Alright fellas, you can see that we have only one branch on our this local repository. So I can use the git branch command to see the branches. So it has only one master branch, and also I can use git branch -a to list down all the branches. For instance, let me go to any other directory repository, and you can see it is also git status, and it is on main branch. And now I can see git branch -a if there are any other branches. So there are also other remotes. Similarly, if I go to sharks node directory, and this is also the repository I just cloned in front of you, git status, and it is also on the main branch, and git branch -a or -a, it shows all the remotes, all the branches. So there is only one branch, just like we have in our DevOps repo repository. And git status, git branch -a, it lists down all the branches. Now let's create our first branch, git branch -b, or I can just type the name of that branch as, for instance, this is feature 1.0.1. okay, now a new branch has been created, git branch -a, and now you can see all the branches. And for instance, if I create another branch, git branch and it is bug 1.0 git branch -a, and it will list out all the branches using git branch -a command. Now you can see I am on master branch, and I want to switch to feature 1.0.1 branch. Then I can use git checkout command to switch and the branch where I want to switch. So git checkout, and now I can again check the git status, and it says that I am on this branch, feature 1.0.1. Or I can also use git branch -a, and you can see the status, this pointer has been also changed, and it is pointing to feature branch. For instance, if I want to switch to bug branch, then I can use git checkout command, git checkout and the branch name. And now I have switched to branch bug 1.0, and now I can see git branch -a, and this pointer has been changed, and it is now pointing to bug branch. And similarly I can see, and it is git status saying that I am on branch bug 1.0. Now if I want to create another branch and at the same time I want to switch to this branch, then I can use another switch, git branch git checkout -b, create this branch bug 1.0 1.2, and also check out to this branch. Now I can see git branch -a, and a new branch has been created, bug 1.2. We have switched from bug 1.0 to 1.2. So I can check out to the new branch, and I have created a new branch using the same command. Similarly, if I want to create and check out, -b is used to create the new branch. Okay, and now I can use feature 1.0.2. Now what will happen? It will first create a new branch, feature 1.0.2, and our branch would be switched from bug 1.2 to feature 1.0.2. I hope that now you understand it. So I can use this, and you can see git status as well. and we are on branch 1.0.2. So for instance, if I am at feature branch and I will create another branch, git branch release 1.0.1, okay, and I want to have this feature into this release. My release is ready and I can now merge. I want to merge the feature branch into the release branch. So first of all, I can check that I am on feature 1.0.1 as 1.0.2, and now I will add feature.txt. This is my feature, and I can comment git add and git commit -m my new feature. Now I can see the working tree is clean. -a, I'm on feature branch and this is my file git feature.txt. Okay, this is my new feature. Now I want to merge this feature branch into release branch. Now first I will switch to release branch, git checkout. Sorry, I was just writing check switch, and this is my branch. Now I can list, and you can see that I am not finding, or I can't see this feature.txt file on release branch. Okay, you can see I don't see the feature file. I can't see the feature file on release branch. Now I can merge, git merge and feature branch into release branch. Okay, I will merge, and now you can see that one file has been changed, one insertion, and I must see feature.txt here as well. So that's how we can merge the branches. For instance, again, I'm repeating this exercise, git checkout feature 2, and now I can create another file, nano third feature .txt. This is my third feature, and I will commit git commit -m third feature, and now I can see that there are 3 files in total. But now I will switch to git checkout release, and now I must see only 2 files because the third feature has not been merged. Now what I will do, I will just use git merge command, git merge and feature 1.2. so you can see that I now have third feature file as well, and there must be 3 files. And that's how, guys, we can merge 2 different branches, and we can get the output of one branch into any other branch. So git merge is a simple command. You have to merge git using git merge as git merge and the branch name. So now I have another branch, git branch -a. I have this branch, and now I want to merge another feature from this branch into release branch. Then I can use git checkout and feature branch. Okay, and you can see nano fourth feature .txt. This is my 4th feature, and git add git commit -m 4th feature. Okay, now I will merge this 4th feature into release branch. So first of all, I have to check out release branch. That's how it works, guys. Now I can merge git merge feature this branch. So merge branch this into release branch. I will say yes, yes. And now the branch has been merged. I can check the status and it is clean. I can also check the commit, git commit, git log -1, and you can see the head is pointed to, and merge branch into release branch. So that was the last commit, and I can see the fourth feature. Now I can see git log -1, and for instance, if I want to revert this comment, okay, you can see now this head is pointing to two branches because the branch feature has been merged into release 1.0.1, and I want to revert this commit. Now I can use git revert and the commit id, okay, and I want to revert this change, okay, then I can use it. So now I can see the status as, and the file has been changed, and now you can see that the third feature has been removed. Now for instance, if I want to revert the commit, any other commit, then I can nano first file.txt, okay, and for instance, just to test the commit revert, and I want to see git status, and this file has been modified, and now git add and git commit -m, I will revert it later. Now I can see the git log -1, and I want to revert it now, okay, so I can use git revert and the commit id. This is the commit id, and I will revert it. So you can see the file has been changed and the commit has been reverted. So I should not have the file, this file was changed, actually this file was modified, and now I can see this file should not have that commit. So that's how we can revert any commit. I hope that now you understand git revert and the commit id to revert any commit. Okay guys, now I will move towards the sharks node repository. I have cloned it from my GitHub account. Now I can see the URL of this remote repository. So I can run this command git remote -v to find the URL. Okay, now you can see this is the origin and this is the URL. I can just paste this URL and I will be able to find this repository on github.com. So this is actually how we can find the URL of any remote repository. Git remote -v command is used for that. Now you can see I have this, and this is the same URL I have here on my VM. So git remote -v is also a very important command to find the URL of any remote repository. And now you can, this is actually on the main branch, and for instance, if I want to pull the changes, if there are any changes, for instance, let me see, git pull origin main, and I am just pulling the changes. It is saying that already up to date, there are no changes. So let me create one change, and I will just add a new file here, and I will name it as testing, and I will just name it as test origin.txt. I am just testing git pull origin main command. Now I have made this comment, okay, and I have changed my main branch, and there is a new file added into this branch. Okay, and you can see it here. Test region has been added just now. Okay, now I will pull again git full region main, and you can see there should be one more file has been pulled, and I have this. And again, if I now run again, and everything should be up to date. But let us make another change, guys. That's how you should play with git command. Make changes, run the commands again and again, again testing git pull command. And now, oh sorry, control Z, and comment the change. Everything was updated, but now there is another change. So I will run git pull region master. If I run master, then it will throw us some error that this is not the origin. Okay, uh, you can see cannot find remote. Now I will run git pull region main. Origin is the point, and we must able to see that this file has been changed, and I can find this file, and again testing git pull command. So that's how, guys, we can pull the changes from our remote repositories, any branch, and we can have those changes on our local VM. So git pull is actually the command that developers also talk to each other, that guy, fella, my brother, you can take the pull of my this branch ABC, you can take the pull, the changes are there on that branch, you can just take the pull. So that's how we can take the pull of our main branch and any other branch. So for instance, now I again change it, and testing git fetch. There is another command, git fetch, and what's the difference between git fetch and git pull? Git fetch just lets us know that there is something changed in the file, but it does not download that file. Whereas git pull not only tells us the changes in the files, but also downloads those files. Now I will just run git fetch region main. Okay, and it has told us that there has been change in this file, in this region main. But what are those changes? I cannot find those changes here in the test region. You can see I don't have, the files are not the same. We don't have this testing git fetch. But if I run git pull command, now this file would be updated as well, git pull region main, and I can run cat test region, and you can see our file has been updated with the changes. So that's the difference between git fetch and git pull. Git fetch just lets us know that there are some changes in the files. Now if I run git status and everything is clean, but again if I change the file, no fella, let's check git fetch again. And if I run if I commit this file and git status, this is clean. Now again git fetch pull region, and make sure you have the git fetch region main, and you can see that there is one change. And what is that change? Testing git fetch is the last line, but we don't have this change. No fella, let's check git fetch again. Now I will run git pull origin main, and I will have this change on my VM. So now you can see cat test origin, and I have this change. So that is the difference between git fetch and git pull, and that is one of the most important interview questions, that what is the difference between git fetch and git pull. Okay guys, now I am in my local repository, and if I want to check if it is linked with any remote repository, then I can run git remote -b, and there is no connection of this local repository to any remote repository. So I can add a remote origin using git add remote origin and the remote repository URL. Okay, that is how we can link. Sorry, the command is git remote add. I'm sorry, git remote add origin and this. Okay, now I can see git remote -v, and we can find this origin. But since I do not want it for now, I can remove this origin, and that's how we can add a remote repository and link it with our local repository, and that's how we can remove the origin with git remote remove origin. Now git remote -v should not show us any remote origin. Fellas, now I want to create some changes, and I want to push those changes into my remote repository. Now I can create a new file, nano testing push.txt. Okay, I will now pushing a change into the remote repository. Now I can push git status. You can see this file has been changed, and there shouldn't be any file with this name here on my remote repository, and I can see that there are no files, there is no such file. Now I can git add and git pull git commit -m, pushing the change to remote repo. Now I will use git push command, and it will push to the remote origin. But you have to use this token as well. You must I have been already authenticated. I will let you know how we can authenticate with our remote repository. Now I have this file, and I will just refresh it, and you can see that I have this DevOps girl as my global username, and pushing the change to remote repo, and you can see this is my testing push command, which is pushed now and pushing a change. So that's how we can use the git push command to push any changes to a remote repository. Now if I create some more changes, and for instance nano dio script, and I am changing this script file, and I will change nano test origin file. So there are a couple of changes, and I want to push all these changes at once. Then I can use git push -force. Git add. I will have to use git add, and I can use git commit -m testing force -m. Now git push or we can use git push force, and since everything is now up to date, so we can use this command to forcefully push the changes. We can also use git push all to push all the changes, at once, and these are the commands, because since everything is up to date, then we can use these switches to forcefully push. And if I want to make all the changes and I want to push all those changes at once, then I can use the git push hyphen hyphen all command. Now you can see that this script has been changed. I will revert the changes. By the way, this script was changed, so that's how we can push and forcefully, and we can use hyphen hyphen all to push all the changes at once. Okay guys, now let's understand git stash. So this is my file, and let us suppose that I am creating some change. I'm modifying a file, testing git stash, how it works, and let us save this. Okay, and I will run git stash save. My changes have been saved on a temporary basis. Now for instance, if I run git stash show, you can see that one file was changed and there was one insertion. But now again I run git stash show minus p, it will tell us that this was the change that was that was made or created in this file. I mean that this file was updated, this file was changed. And now I can run git stash minus u, and it also tells us that only one file was changed. Now I want to switch to any other branch, git checkout release. And now for instance, I have finished up my work on this branch and I want to move back to the main branch and git checkout main. And now I want to see what was my last change, git stash show minus p, and you can see that this was my last change. And now I can continue work. My work was saved on a temporary basis. Now I can continue from here. So git stash actually saves your changes on a temporary basis. You can see those changes with git stash show command, git stash show minus p commands, and then you can carry on your work on that specific branch. So git stash is a must try. You must try and check out how it works, and then how it saves your data on a temporary basis. I have two branches, release 1.01 and main branch. Now I will make some changes and I will rebase those changes into release 1.0.1 branch. So we will now check how git rebase command works. Let's do this real quick. And git status, I am on main branch, nano test rebase.txt. This is a rebase test. Okay, a rebase actually copy all the content from one branch to another branch. We will see now. Git add and git commit minus m, checking rebase. Now git checkout release, and I am here. I should not find this file checking rebase here. And now I can use git rebase main. So it is saying that successfully rebased and updated this branch, release branch, with the main branch. So now I can see this file here, and it is test rebase.txt, and I can see test rebase, and you can see this is a rebase test. release branch is rebased from the main branch. So anything happening in the main branch will automatically reflected, or it would be automatically changed in the release branch. Now I create any change in do script, so checking rebase, and I can now switch to git checkout release branch, and I can see that this file has been changed. So I run git status, you can see that this file was modified. So now we can see that release branch is rebased from the main branch. Anything, if any change happens on the main branch, it is automatically reflected on the release branch. So guys, that's how rebase works. We can rebase one branch onto another branch, and in this example I have rebased the main branch onto the release branch. Okay, now let's suppose that I do not want these files, and I will just remove these files here, and since I don't need these files, I will just remove them. And now I can check the git status, and it is showing that these files have been deleted. But then I realized that I needed those files, so I will check the status and I will just reset. You can see unstaged changes after reset, and these files were deleted, but I do not have these files still on my VM. And now I can run git reset hard, and you can see I should have these files back on my VM. So that's how, guys, we can get our unstaged files back using git reset. And if it does not work, we can use git reset hard to forcefully get those files. For instance, if I remove this Docker file, okay, rm-fr, and this file has been forcefully removed from my git repository, but now I can check git status. You can see this file has been deleted, and if I run ls-l, you can see I do not have this file, Docker file. If I run git reset hard, then I will get my file back, and now I should able to see Docker file here, and git status, my working tree is clean. So that's how, guys, git reset and git reset hard works. Normally we use git reset hard to bring our changes and to reset the git commit. Okay guys, now the last command is the git reset commit command for git commands. Then we will discuss 10 GitHub commands as well. So for instance, git log -3, and this was my last commit, and you can see previous changes and testing force. For instance, I want to move this commit on to this position. I want to move this commit from third position to the first position, so it becomes the tip and the most recent commit. Then I can use this command, git reset commit id. Okay, now what, it was on the third position, and I have moved it from this position to the tip to the first position. So that's how we can use the git reset commit id. And now we can see the git status, git commit -3, git log -3, and you can see I have this commit has been 869 and I have this commit as my most recent commit. For instance, if I want to move this commit to the first position, then I can use git reset and the commit id. Then we will have update origin.txt as our last commit git log -1. You can see this, how we can update the commit, and we can change their position from any last position to the first position. All right, fellas, now let's discuss around 10 last 10 commands regarding GitHub CLI. So you can see we have installed GitHub CLI on my VM. So GH is the command, GitHub, G stands for Git, H stands for Hub, and works seamlessly with GitHub from the command line. So we can work on our GitHub repositories that are hosted on GitHub using this GitHub repository, this using GitHub command. And you can see these are the core commands like repo, release, pull request, issue. So we can manage using the GitHub CLI. So it is actually CLI. We can also manage our actions, workflows, etc. So now let's create an empty repository, mkdir testing GitHub CLI. Now this is my new empty repository. I will initiate it, and now you can see we have initiated this local repository, and I will create a file cli.txt. This is our GitHub CLI, and I have this command git status. I will just add it, git add git commit -m first commit. Okay, now I have this repository on my local VM, and I want to have this repository with all of these changes, comments, files on my GitHub repository. You can see I do not have such a repository here on my GitHub account with testing GitHub CLI, and I can go to the repositories, and you can see I have all these repositories here, and I do not have any of such GitHub testing GitHub. You can see I don't have this repository on my GitHub account, but I want to have this repository on my GitHub account. Then I will first use the GitHub auth login command to log in to my GitHub account, and I will use this as, since it's for my personal use, I do not have any enterprise server. I will use GitHub, and then HTTPS. Okay, if it's not clear to you, HTTPS, and log in with the browser or paste an authentication token. So I will log in with browser, and I have created this token. This is my GitHub token. You can see how Git works, and I have told how we can create personal access tokens in that lecture. Now you can see I have logged in as Fasi Khan. This is my account, and now I can use GitHub CLI, and my GitHub commands should work without any issues since I am logged in. I will push this local repository on my GitHub account. So I will use GitHub repo create this command, and I will run it. So it says that create a new repository on GitHub from scratch or push an existing local repository to GitHub. So I will push this local repository to my GitHub account. So I will use this one. And now path to local repository, I will just enter. There is nothing to change, or repository name, the same name, and I will press enter. Description and public or private, I want to have it as private. And created, you can see created repository Fasi Khan this on GitHub. Add a remote, yes, I want to have a remote, and it is origin. And would you like to push comments? Yes, I would like to push the comments as well. And our repository has been pushed with the commits, with the changes, and this is the URL. I will just check with the URL, and I must have this repository on my GitHub account. So guys, you can see I have this, and this is my first comment, and I have this file as CLI. This is our GitHub CLI. So that's how we can run GitHub CLI to manage repositories on our from our Linux, from our Linux VM. For instance, if I want to rename it, now it is actually GitHub testing GitHub CLI. You can see it is this repository name, and I want to rename it, then I can run GitHub repo command, and it will show us a number of other commands that we can use. For instance, if I want to rename it, then GitHub repo rename, and it says that rename this to get testing GitHub CLI. I would just testing CLI or CLI game, and now it has been changed from testing GitHub CLI to CLI game. Okay, if I want to check it, let's see if the changes have been reflected. Okay, now you can see that it is CLI game, and my repository has been changed, the name has been changed. Similarly, if I want to remove or delete it, GitHub repo delete. This is, by the way, dangerous command. So yes, it says that type Fasihan this to delete, confirm the deletion, and I have deleted my repository. Now I should not have any repository on my GitHub account. It must show a 404 or page not found error. So that's how, guys, we can remove. And after doing the changes, after working, we can log out. GitHub auth log out, and I am logged in. Yes, so that's how I can log back in. auth login, and authentication token, and I can paste the authentication token here, and that's how I can log back in. So a couple of more commands and actions for CI/CD pipelines that are our next target, and we are going to move with CI/CD after Git lecture. This is the second last lecture we have. In the next lecture, we will have GitHub interview questions and answers. Sorry, Git interview questions and answers. So that would be our second last lecture on Git. After that, we will definitely move towards CI/CD, and we will definitely work on Jenkins and GitHub Actions. So that is how we can see the GitHub workflows, GitHub Actions. And for instance, I do not have any GitHub Actions on this repository. I will go into LAMP, and this is also my repository. Now I can check GitHub Actions, and if I want to see any recent workflow runs, I can run run list, and you can see there were 21 days, and there were some changes in the .environment file, and there were changes in the readme.md file. So that's how we can see the recent workflows, and also GitHub run view, and that is actually the last workflow that was run, and that's how we can check any workflow with the run ID. So these are a couple of GitHub Actions workflow commands, and we will definitely work on these GitHub Actions work commands in our CI/CD lectures. Guys, my apologies if this sounds overwhelming to you, but we will definitely have a deep dive into CI/CD, and we will work on these GitHub Actions commands and GitHub Actions GitHub Actions CLI to know the workflows both from our GitHub account and from our Linux command line CLI. So that's for today's lecture. I hope you have got all these commands, and I will definitely share the GitHub repository link so that you can find. I have already added these commands on my uh, GitHub repository. All these commands, these are 50 commands, so that you can run each command and polish your Git skills. So all these commands with their brief description is mentioned, and I will definitely share this URL with you guys so that you can run and practice as much as possible. The next would be our last lecture of our GitHub section and Git. So we will have around 50 Git important interview questions and answers. Make sure, guys, to subscribe and share this video and subscribe my channel. I will see you in the next video.